Computing in the Australian Defence Department, VR number 19580. Take one.
The subject of my address is computing in the Australian Department of Defence. During the time allotted to me, I shall review briefly each of the broad areas in which computers are used in the Defence Department. I will then focus on strictly military or operational applications to illustrate the current level of activity in this particular field, which probably for most of you will be unfamiliar territory. Next, I'll try my hand at crystal ball gazing by attempting to predict future developments in defence computing and their impact on employment patterns. Finally, I'll give you an outline of the career opportunities, qualification requirements, and methods of entry for both service and civilian personnel in the various fields of computing in the Defence Department. Before I start my subject, I should make it clear that I'm neither a computer nor programming expert. I joined the Navy over 30 years ago when the Naval College was at Flinders Naval Depot, some 80 kilometres south from here. In 1958, I graduated in electrical engineering from the University of Melbourne and have worked as a naval weapons engineer for most of my career. I met my first programmable digital computer when doing courses in America in 1965, and more or less have had a fairly close association with computer systems ever since. From 75 until 78, I was a systems engineer at the Navy's first programming centre for operational computers. And for most of last year, I conducted a study into the impact that operational computers were having on the organisation and management of the Navy. My present job as a staff officer to the Chief of Naval Technical Services has brought me into contact with a variety of computing applications in the Army and the Air Force. As a result, I can now talk to you about computing in many areas of defence and not just Navy. Although, of course, I know the Navy applications much better. Computing within the Australian Defence Department and the Defence Forces is divided into three broad categories, namely administrative, scientific, and operational. Administrative applications include systems for maintaining personnel records, stores cataloguing, inventory control, pay and other financial accounting, project network scheduling, and equipment maintenance management, and a host of many other applications. Scientific applications are in support of defence research and development activities and include complex calculations, data analysis, mathematical modelling, and information retrieval. Operational computing encompasses all applications either in or in direct support of military operations, such as surveillance and detection, command and control, communications, and weapon control. Computer-based operational systems are now fitted in ships, submarines, aircraft, land fighting vehicles, as well as being located in static sites on land. I shall now return to administrative systems. Most of the activity in administrative computing takes place within the Defence Computing Services Division in Canberra, where all bar one of the mainframe computers for this purpose are located. Between 1962 and 69, 8 Honeywell computers of 4 different types were installed in Canberra. Over the years, these machines have performed the bulk of the administrative computing work, but they'll be phased out when all the old programs have been converted to run on 2 U-Matic machines, which the department recently purchased. In addition to the Honeywell and U-Matic machines in Canberra, the department has a Burroughs B1726 for administrative work at the Defence Regional Office here in Melbourne. The department also makes use of the CSIRO computing facilities in Canberra and many commercial bureau services around the country. Besides the mainframe computers I've just mentioned, at last count, Defence had 76 Perkin-Elmer mini computers in use and about another 30 in the process of being brought into use. These machines are dotted around the country, and the great majority either are or will be used for administrative applications. Again, all the application software is developed in Canberra. Desktop microcomputers and word processors have really only recently appeared around the Defence Department, but they're in great demand, and it isn't difficult to predict that many more will follow in the not too distant future. At present, the application software for these equipments is normally a standard commercial package bought with each different machine, but an increasing number of microcomputer applications will require software uniquely tailored to a particular task. Scientific computing is centred around an IBM 370 system at the Defence Research Centre at Salisbury, just north of Adelaide, and a DEC System 10 at the Aeronautical Research Laboratories at Fisherman's Bend here in Melbourne. In addition, the Defence Science and Technology Organisation has about 70 mini-computers of various types spread around its different laboratories, mainly for scientific work. Now, having briefly covered the administrative and scientific categories of defence computing, I'll now move to the operational field. Here, each military service generally does its own thing, although from time to time they obtain advice or assistance from either the Computing Services Division or the Defence Science and Technology Organisation mentioned previously. Just to refresh your memories, operational computing covers all applications in or in direct support of military operations, whether on land, in the air, on, or even under the sea. Unlike the computers used in administrative and scientific applications, those in the operational field are usually just one element in a much larger system whose function has nothing to do with computing. The use of computers in this way is very similar to industrial control applications. To illustrate this point and some other aspects of operational computing, I'll now briefly describe a number of systems which are either already in service or under procurement. I shall start with systems used by the Army. The Leopard tank shown in this first slide was purchased from West Germany. It contains a small computer with a program which calculates the optimum point of aim for the gun using information supplied by a very accurate laser rangefinder. The calculation also takes into account factors such as the type of ammunition to be fired, barrel wear, atmospheric conditions, and of course, movement of the tank itself. The computer output is used to automatically correct the gun aimer's sight, rather like adjusting the sight on an ordinary rifle, and thereby increasing the likelihood of a hit with the first round fired. Another weapon system recently acquired by the Army is the Rapier anti-aircraft missile system shown in the second slide. Rapier is a British system specifically designed to defend ground forces against low-level attack from the air. By continuously observing the intended target through a pair of special binoculars and with the aid of the inbuilt computer, one operator can identify and destroy low-flying aircraft. In this case, the primary function of the computer is to advise the operator when the target is within missile range, and then, when the missile has been fired, to command it to fly in the direction of the line of sight of the binoculars. Thus, all the operator has to do is to keep the target lined up in the crosshairs of his binoculars until the missile flies close enough to the target for the proximity fuse to detonate the warhead. Again, the computer is only one component of a system. In this case, a missile fire control system which extends from the operator with his binoculars through to the missile itself. The next Army computer is unlike the other two in it is more a standalone equipment rather than part of a system. The Field Artillery Computing Equipment, or FACE, is used to direct the firing of a battery of field guns. Different target coordinates are entered and stored in the computer via the keyboard. So too are the positions and characteristics of each gun, the characteristics of the different types of ammunition, air temperature, and wind velocity and direction. Once this has been done, the FACE operator then only has to select a target for the computer to calculate and display at each gun the corresponding point of aim for that gun. FACE not only improves the accuracy of the guns, but it allows the battery to quickly change to new targets. The computers and their software in the three examples I've just described were produced overseas and bought off the shelf by the Army. They're all relatively small and simple devices, and although their hardware will be repaired and maintained in Australia, their software is unlikely to require much local support effort. Army does, however, have a large system in its AutoMap, a computer-aided mapping system which the Royal Australian Survey Corps has had at Bendigo since 1976. This system contains 5 separate subsystems, each controlled by its own mini-computer. It was designed by a joint team from the Survey Corps, the Defence Computing Services Division, and the Canadian manufacturer. The software is now largely maintained by Defence personnel. Well, now for some examples of operational computing in the Air Force. By far the largest and most complex computing task to be undertaken by the Air Force is for their P-3C Orion anti-submarine aircraft like the one in this slide. Although the aircraft and some of its avionics systems were bought from the USA, the RAF, with the aid of a number of Australian companies, has produced a sophisticated computer-based system which, when fully operational, will greatly assist the crew of the P-3C to locate and identify submarines. The system is designed to receive signals from the Australian-developed Barra sonar buoy, which, when dropped in the sea, transmits data about events under the surface. The computer in the aircraft analyses these data and displays the results for interpretation by the crew. While the computer itself was developed in the UK for a similar purpose, the program for the Orion was designed and developed to Air Force requirements by an Australian company. The same company is producing the software for the automatic test equipment, which will be used to check out the P-3C on the ground. In addition, a ground computer centre, specially built to generate the programs and test the complete system before it was fitted in the first aircraft, was recently transferred to the RAF base at Edinburgh in South Australia, where it will be used for post-mission debriefing and analysis, crew training and program maintenance. From my description of the P-3C system, it should be apparent that its development has been a big project involving many Australians in a wide range of operational computing activities. Australian F-111 aircraft, like the one in this slide, do not yet carry a digital computer, but one is used to test the aircraft while it's on the ground. The computer is programmed to automatically step through a sequence of tests and monitor the responses for each of the systems in the aircraft. By plugging the test equipment into the aircraft, the ground crew can quickly determine its serviceability and locate faults without removing any item from the aircraft. Another computer is used to drive the F-111 flight training simulator, now being installed at the RAF base at Amberley in Queensland. The RAF has 4 other computer-based simulators for pilot and aircrew training. 2 are at Richmond, to the west of Sydney, for the C-130 Hercules transport aircraft, and 2 are at Edinburgh in South Australia for the P-3 Orion maritime patrol aircraft. The government has approved the purchase of 75 new fighter aircraft for the Air Force, but has not yet decided whether to buy the F-16 or the F-18 from America. Both are modern, high-performance aircraft containing at least one mini-computer and a multitude of microprocessors. For instance, the F-18, which is the larger of the two, contains something in excess of 20 separate digital processors. Because my time is limited, I shall only discuss one of them, and because I found it easier to obtain its photograph, I've selected the F-16 shown in the next slide. In this aircraft, the avionics fit includes a flight control system, a payload management system, a fuel measurement system, and an inertial navigation system. All these systems contain microprocessors which are connected to a common data bus, and the whole is controlled by the program in the fire control computer. Principal features of this system include distributed architecture, modular software, and a high-order program language. The net effect of all this clever stuff is to reduce the physical and mental burden on the pilot and allow him to concentrate on the essential tasks of flying and fighting his plane. Even though the software for the F-16 and F-18 has already been produced, it seems likely that the RAF personnel will be required to maintain the programs for the life of whichever aircraft is eventually bought. Moving now to the Navy. The 3 guided missile destroyers, like the one in this picture, each contain 5 digital computers, and more are planned. At the moment, one is used to control the operation of a radar. Another 2 are used in the 2 Tata anti-aircraft missile fire control systems. The 4th is in the ICARA anti-submarine missile system, and the 5th is at the heart of the Naval Combat Data System. In view of my time limit, I shall only discuss the last 2. The ICARA system was designed and developed in Australia in the early 60s. While its computer performs a variety of tasks, its prime function is to guide a rocket-propelled, radio-controlled aeroplane so that it drops a homing torpedo into the sea near a target submarine. The software for this system was developed by the staff at the Defence Research Centre Salisbury and is now maintained for the Navy by an electronics company at Salisbury. The Naval Combat Data System, which keeps track of all aircraft, ships and submarines in the vicinity and assists the ship's command team to use their weapons to best advantage, is an Australian-designed variant of an American Navy system. Its computer, which is similar to the one shown in the next slide, is the most powerful in any of our ships. It goes by the title of AN UYK7, or more commonly, YUK7. The large and complex program for this system is maintained at the Navy's Combat Data Systems Centre in Canberra, where for the past 5 years the staff has been kept very busy producing some clever enhancements to the software. This next slide shows a guided missile patrol frigate like the 4 now being built in America for our Navy. These ships also have a combat data system very similar to the one I've just described, and in due course its software will also be maintained at the Combat Data Systems Centre in Canberra. The gun and missile systems in these ships are also controlled by a second YUK-7. Other different computers are used in the sonar system, the electronic warfare system, and in one of the communications systems. In addition, there are quite a number of microprocessors in one of the radar systems, and also in the system which controls the 2 gas turbine engines and the variable pitch propeller. In all, a lot of software is used in these ships, but before too long there's likely to be much more. Some of this additional software will probably be designed and developed in Australia. Another noteworthy computer-based system is right now being installed in one of our submarines, like the one in this photograph. Eventually, all 6 of our subs will be fitted with this system known as Submarine Fire Control System, or SFCS Mark I. This system assists the crew to keep track of events in the outside world, and if the need arises, to fire either their torpedoes or anti-ship Harpoon missiles. At the heart of the SFCS is a mass memory unit and an AN-UYK-20, or YUK-20, a small brother of the YUK-7. This system, including the software, was designed and built in America to Australian Navy specifications. We believe it's a world leader in its class. The software is now maintained at a special training and computer support centre at HMAS Watson, a naval training school in Sydney, and I can assure you that the computing staff there has plenty of interesting and challenging work to do. In addition to the Submarine Support Centre, Watson has a very large training simulator in which the operations rooms of 3 different classes of ships are duplicated and driven by 4 computers to provide realistic training for ships' crews and to allow the training staff to monitor their performance. The software was produced by a contractor but is now maintained by civilian programmers on the staff of the school. Navy has or is acquiring many other operational computers, which I don't have time to discuss. But before I leave this section, I just must mention the Maloka sonar for seeking out submarines. This successful computer system, including the software, was developed in Australia and is already fitted in 1 ship with more to follow. I'd now like to take a look into the future, but before I do, I should point out that the views I'm about to express are my own and are not necessarily those of either the Department of Defence or of any other department official. Firstly, it's safe to assume that nearly every operational system acquired by our defence forces in the future will contain some form of digital processor and hence software. Microprocessors will be everywhere. More and more systems will be integrated with their computers connected either via a data bus or radio data links. This will involve complex software and architecture and force us to a common high-level language, better programming standards than we have at present. In this regard, some of my colleagues are closely monitoring the development and progress of Ada, a new language based on Pascal, which is being developed by the US Department of Defense. Before long, the differences in the military strength between countries will depend as much, if not more, on their software than their hardware. This situation is likely to lead us to producing much more of our software in Australia, although cost factors may dictate that much of the hardware will still be purchased from overseas. Increasing automation is likely to reduce the number of people in the battle zone, but I think, at least here on Earth, it will be a long time before people withdraw altogether and leave robots to fight their battles. Because of the high cost and long gestation period of operational systems, the transition will be relatively slow. So it's most unlikely that people now in the services or related industries will be disrupted or become redundant. On the other hand, many more people, computer people, will be required by both the Department of Defense and the local industry to develop and support these new systems. There's already a great shortage of engineers and programmers with knowledge and experience in this field, both in Australia and overseas. This shortage will not only continue, but it's likely to get worse and affect the progress of all types of computing, not just in the operational field. The supply of trained people simply will not keep up with the demand, particularly overseas. And the computing industry will be forced to develop new techniques and technology to reduce the need for specialists. I believe this will happen well before the end of the century, and when it does, the jobs of some highly paid computer people could be threatened. Now, I don't want to alarm those of you who are about to enter the field. There will always be good jobs for systems analysts and clever programmers, but the long-term prospects for the run-of-the-mill programmer with no other qualifications might not be so bright. For those of you who see yourself in this latter category, I'd recommend you try to obtain qualifications in a second field as a backup to your computing. For example, any of the sciences, economics, or accounting. In fact, any field in which computers are likely to be used would do. Of course, the profession with the most assured future in computing is engineering. Engineers of all persuasions will use computers, and those specializing in electrical, electronic, or communications engineering can hardly avoid becoming involved in either design, production, or maintenance of computer systems, including their software. I'd now like to return to the present-day employment opportunities in the Department of Defense. First, I shall deal with the civilians in the administrative computing field. The Defence Computing Services Division has a staff of over 700 civilians and about 100 servicemen and women. Of these civilians, over 300 are programmers, or to give them their correct public service title, Computing Systems Officers, CSOs. The remainder of the division staff includes about 100 computer operators and slightly more than 100 data preparation officers. In order to maintain these numbers, the department is forever seeking new recruits. For example, over the past year, 85 CSOs, mostly at grade 1, were recruited, and this year we're looking for about 60. Job vacancies are advertised in the Australian Government Gazette and most daily newspapers. Entry into the department is through the Australian Public Service, which gives the entrant the opportunity to work for any government department, not just defence. Applicants to become CSOs in the Australian Public Service are selected for interview on the basis of either their tertiary qualifications or evidence of knowledge and ability to undertake the work, or a combination of both. Most degree or diploma courses in computing science, data processing, or information science satisfy the basic requirements for CSO grade 1 without any additional training. But I'd strongly recommend that anyone interested in following this path obtain further information from the nearest Commonwealth Government Centre, which here in Melbourne is at the corner of Spring and La Trobe Streets. Computing within the Defence Science and Technology Organisation, whether for scientific or operational applications, is done mostly by engineers and scientists, even though the DSTO does employ nearly 50 CSOs. All these specialists are civilians and members of the Australian Public Service. The services, more particularly Navy, also employ civilian public service engineers and CSOs in computing work, mainly in connection with the operational field, and the numbers are increasing quite rapidly. As for the uniformed members of the Defence Force, it's a different story for each service. Army personnel are very much involved in the design and use of administrative computing systems, but have little to do with the software in computer-based operational systems. The Air Force is well into both fields, and while the Navy is up to its neck in operational computing, it has relatively few people working in the administrative field. Except for a few computer and data processing operators in both the Army and the Air Force, no serviceman or woman is officially designated as a computer specialist. However, a steadily increasing number is now employed in some aspect of computing. Very broadly, it's the service officers who are involved in computing activities such as systems analysis and design, the management of new development projects, and the oversight of the operation and maintenance of computer-based systems. Other ranks are more likely to be found as either operators or maintainers of computer systems. Time doesn't permit me to describe all the methods and qualification requirements for entry into the service, but it's worth noting that entry as an officer is more likely to lead to tertiary qualifications and experience in a computing field than enlistment as a sailor, soldier or airman. On the other hand, service apprentices are more likely to gain trade skills and practical experience in the repair of computer equipment. For those interested in a career in any one of the services, I recommend you contact your nearest Defence Forces Recruiting Centre for further details. In Melbourne, the centre is at 301 Flinders Lane. From my own experience, the Defence Forces provide ample opportunity for an interesting and rewarding career, even if not wholly devoted to computing. That concludes my address. Thank you for your interest.